So welcome back, guys. Let's get started with design and simulation of a CMOS inverter. So yeah, I'm afraid that this video may be a little bit long, maybe up to 10 minutes, so or I may just cut it short 5 as usual. So because I think I would have to, take you guys gradually into the use of this interface. For some of you it may be new, so that's why I think it will be a little bit longer. And yeah, so to give you an idea of what we're designing, it's the text, one of the texts the course uses. That's microelectronic devices and circuit by Owe and Sodini. So yeah, so this is what we're going to be designing. This is CMOS inverter here, so that's figure 5.18C. yeah. Though I talked about the importance of valid specifications for this demonstration, there's no we're not going to be working with any pronounced specification somewhere. I'm just going to be picking devices and all, but since I talked about having the importance of having valid specification, I'm still going to do it even if I'm not following any written down specification somewhere. I'm still going to do it in a way that that still makes sense. In a way, I am following specifications, I'm following the theoretical principles you get. So yeah, that's how we're going to do it. So maybe for your own assignments, then it will be with specified specifications. So yeah, let's get started. So yeah, you can recognize a PMOS device, an NMOS device, and an output capacitance here. For some CMOS inverter, you may not see this output capacitor here, but why it's there, it's there to model the expected load of the CMOS inverter. Usually CMOS inverter, it's digital, it's going to be in digital circuit. So at the output may be another CMOS device. It may be a gate, NAND gates, NOR gates, or AND gates, or anything else that it's also designed with CMOS. And usually, and it may have to go through the gate of a CMOS, and at the gate of the CMOS, that's or a MOSFET, you have a basically capacitor, right? Just between the gate and the source, right? You have capacitor. That's one of the intrinsic capacitances. I think the oxide capacitance. Yeah. So that CL there, we're just modeling any load, any capacitive load, and which is very valid, because for the digital circuit, everywhere would just be MOSFET, and most likely it will be the gate of the MOSFET that will be connected to this output, and the gate of the MOSFET as a capacitance. So we're trying to model what the environment the inverter will be working in. So the environment is filled with capacitive loads. So let's get started. Okay, when you start up the interface, like I said, for mine it's Global Foundries, but for yours it's going to be Skywater. It's similar interface like this, but I think that of Skywater is more, it looks more aesthetically, I would say. So all you just need to do is, let me cancel this, you click on this, add. So for a new schematics, then you start by adding your devices. So for the CMOS, we have NMOS and PMOS, right? So you come here, you go to symbol, then I'm used to the shortcut, using the shortcut. So is it the symbol? Okay, not give me some time. Okay, so guys, I'll just come here to tools and I click on insert symbol. So for me, I'm used to the shortcut already, so you can see the shortcut, INS for insert, or you press shift I. So I forgot where this from the GUI, how I could access it, so that's why I had to pause. So when you click that, so insert symbol, you will be brought to this, will pop up. If you've done your installation well, you'd see, maybe for yours you have a number of directories here, but you just need 2 directories. They are important. Yeah, the 2 important directories you need are this I have here. You can see the scheme library directory, and the second directory here is, that's this one, is a global foundry. So for yours it will be the skywater directory. So those are the 2 most important. They are important. You get to see their importance as we go on. Each of the libraries contain your components, the devices you're going to be using, the primitive devices, the voltage source, the MOSFET, the capacitors, everything you need for your circuit design and simulation. You have them here. So but when do you use component from this library or this? That's what we're going to also learn here. So I want to pick MOSFET, right? So what I'm going to do, if you come here to the scheme, you just search for NMOS. You're equally going to see NMOS here, but the thing there is that we don't need the NMOS in the scheme library. That's not the NMOS we want. What we want is the NMOS from the PDK. That's what we need. So for yours it's going to be skywater. So you just come here, you click on the skywater library, the other one, then you click on symbols, and you may want to search. So just NFET. So NFET, that's what I need. For the skywater you may be saying 1.8 because that's the voltage for that process node, 1.8. but for global foundries it's 3.3. so this is what I need. So NFET, I click, then okay, I drop it. I need PMOS, right? Now I'm going to be using the shortcut. I just click on the insert button on my keyboard, or you do the shift I. So I'm here again. I'm looking for PFETs, and I'm using this. You need to take note of the device name too. Then I drop it. It's looking too zoomed in, so I want to make this smaller so I can have more rooms here, more space here. So all you just need to do, I think, is the shifts. Okay, I think it's the Control Z. So Control Z. Yeah. So generally for this open source tools, the shortcuts are quite different from your normal software where you can use those regular shortcuts. They tend to be different here. So but it's something you can learn easily. So Then I have these two MOSFETs too close to themselves. I want to just rearrange things to look more okay. So all I just need to do is I click to select the device I want to move, then just press on your keyboard M. So M on the keyboard. When after selecting, then you try to move, then you just over your cursor, so it's going to move. So the same thing, I'm going to select this to move it, then I press M on your keyboard, so M, then it will be movable. So that's what I'm going to do to arrange everything here. So I think, yeah, they're all good. Okay. Yeah, so I would have my power supply, my VDD up here, then my ground down here, then my output in between. Remember, that's how CMOS inverter is. Then I would connect the two gates together. So that's what I'm going to do now. So for me to do the wiring, you come here to this button here, insert wire. So insert wire. So yeah, then you just click on the node you want to join, then move to the other node. Yeah, or shortcuts, you go to the node you want to wire, then you just press on your keyboard W. So W, then you get to where you want to stop. You just click again to abort. Okay, so let me join the gates together. Okay, then so let me just check the time. Oh no. So I'm going to stop here to continue